We're having technical difficulties in the classroom. We'll be right back.
Let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
Delicious things to eat.
The popcorn can't be beat. The sparkling drinks are just dandy. The chocolate bars and the candy. So let's all go to the lobby to get ourselves a treat. Let's all go to the lobby to get ourselves a treat. Let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
Delicious things to eat.
The popcorn can't be beat. The sparkling drinks are just dandy. The chocolate bars and the candy. So let's all go to the lobby to get ourselves a treat. Let's all go to the lobby to get ourselves a treat. Let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
Delicious things to eat.
The popcorn can't be beat.
All right, we're going to have to go with that. At least we've got one screen. Somebody else is coming in here to fix the other screen. So sorry for the folks over here. Hopefully it's not that bad and you can crane over. Yeah. It was broken this morning? All right, so we won't blame that guy, but we'll blame whoever. All right. So to finish up here, I wanted to retread what you did in your lab yesterday. At least most people did. When you were supposed to convert one of those programs to, you were given birthday programs, one of them using interactive input and one of them using non-interactive input using command line arguments. And then you were supposed to convert that area program into non-interactive input. Just a few details on that. Again, when you use scanf, you're prompted for the input, and you're actually reading from the keyboard. Now, the vast majority of programs are not interactive. The vast majority of programs out there are written to interface with other programs. That's the whole point of writing software, is to automate stuff so that you're not having to worry about this kind of stuff. Let me just check. Yep, good. Remember, we are on YouTube and on Piazza, so if you have any questions, you can post to either one of those. But in any case, the vast majority of software is not written for humans, right? And so we want a way to do it non-interactively, where we can just dump the input in to a program without being prompted for one, hit and mash the keyboard, hit enter, prompt for the second one, mash the keyboard, hit enter, et cetera, et cetera. And to do that, you use command line arguments. Every single programming language that I know of supports command line arguments somehow. C supports command line arguments by providing them at the command line. You know, if you've got your executable file here, then you can provide the first one, second one, third one, and you are delimiting them by spaces. Whatever white space you put in there, that's the next argument, the next argument, the next argument. And if you have an entire string, by the way, we're not going to cover it, but if you have an entire string that has spaces in it, you just surround it with double quotes, and it'll keep those spaces and not treat them as delimiters. But this example, the example above, has actually 1, 2, 3, 4, 5, 6, 7 command line arguments. Right? Do you see them all? Well, ABC, that's 3. 10, 20, 30, that's another 3. What's the 7th one? It's the a.out, the executable file name. And that's always going to be the first one. They are available. Let me write this. The number of command line arguments are available in argc, argument count, right? And so if you're expecting a certain number of command line arguments, you can use that variable, the value in that variable, to determine, did they give me enough input? If not, we can quit on them, right? If they did, then we can move on and compute something, right? The first argument is always the executable file name. And for the most part, that's going to be a.out, right, by default. But you could rename that file, or you could compile to a different file, myawesomeprogram.exe or whatever. And that would be provided as the first command line argument. And it is available in argv sub 0. This is actually an array. We'll talk about arrays later on. And they're always 0 indexed. They start at 0. But argv sub 1 is the first user-provided argument. Right? And likewise, argv sub 2 is the second again, user-provided argument, etc. Right? You can go all the way up there. Right? All arguments are strings. They are strings of characters. So when we give 1, 0, we're not actually giving the number 10. We are giving 1, 0 as strings. The character 1, the character 0. Consequently, if you need to convert from a string, an alphanumeric character, or string, to an integer or double, you need to use a function. Right? And the functions that we'll use are a to I and a to f. Right? A to I is for alphanumeric conversion to integers. Right? It converts to an integer. A to f is going to be converting to a float, right? A double in our case. Okay? So now that we've got that understanding, let's go ahead and combine that along with everything that we've done up to this point to do this nice little exercise here, right? That it requires nothing more than, high school math, right? I don't know if this is high school or grade school. I don't know yet. Middle school maybe. I don't know. A squared plus b squared plus c squared, or a squared, ax squared plus bx plus c is equal to 0. That's a classic quadratic polynomial. It's a polynomial of degree 2. What does it mean to find the roots of that thing? Given a, b, and c, the coefficients, you want to find the solutions of x. Those are called roots. What is the tool that we use for this to solve to find roots? Can you get that one up? Somebody was mucking with it manually, and it's not coming up here. Thank you. So there's the exercise. What tools do we use? Both of them?
Yeah.
Okay. All right. What tools do we use for solving quadratic polynomials? Or what tool do we use? There's just one. Quadratic formula. Remind me, what is the quadratic formula again? Negative b plus minus 2 roots, right? Square root of b squared over minus 4ac over 2a, right? All right, so there's where we're going to go. That's what we're going to do today. We're going to just write this program from scratch, okay? Let me go ahead and go into our folder here, and I'll go ahead and call this something descriptive, new file. I'll call it quadratics.c for a C source file, okay? Lecture CSCE 155E. All right. Are we good on the right-hand side at least? Nope.
I'll get the thing.
Okay. There we go. Thank you. All right. So, quadratics. Help me out. What do I start? What do I start with all my simple programs, at least in the first few weeks here? /**, the author documentation, right? And I'm the author, me. The date is 08/31, right? And what else do we put in this author documentation? Well, if we're in a hack and we're working with a partner, what do? We put our partner's name, right? Email maybe if you want. Log in. Do I put my password there? Do I put my GitHub token there? Nope. Right? What else do I put in my comment way up here? Is that big enough for folks over there yet? Oops. That's too big. Say again? Our explanation of the program, or why are we doing this, right? So even if I explained it over here, right, as part of the exercise, you should re-explain it to yourself to know that you understand what the purpose of this exercise is. It helps you formulate a roadmap of what you're doing and why you're doing it, right? So this program reads in 3 coefficients. to a quadratic polynomial and outputs the roots of it. Right? Recall that a quadratic polynomial is blah, blah, blah. You can write a whole entire essay here on the history of quadratic polynomials if you want to, or just put in a link to an external resource on Wikipedia or something. Right? That's good enough for now. All right? What's next? Libraries, because I'm going to be doing stuff, right? And don't want to start from scratch. So I'll include the standard library because I want to do standard stuff. And I also want to include the standard input-output library because I'm probably going to be doing input-output stuff. Prompting for input, making output, printf, scanf, right? What else am I going to be doing? Math. I'm going to be doing mathy stuff, right?
I'm going to have to come back.
Okay.
Because there's something, like, I'm not exactly sure what's going on. I'm going to have to restart everything so
Okay.
it's back in sync.
Sure.
But I can come back later this afternoon.
Okay, thanks.
Yeah. I'll just turn it
All right.
on. Thank you.
All right. So, sorry, is it big enough for the folks over here at least? All right. Okay. Sorry, your seats were chosen poorly today. Yeah, and this code is posted as well. Right? It will be posted. Okay. All right, and then how do I start my program? Every program starts with a main int argc char star star argv, right? Return 0. That's basically the shell of any simple program. You could put that into a template file and then save that template file so you don't have to, you could copy paste that every time you start a new program, right? We're going to quickly get away from these really simple input-output programs, but you could do it for the next couple of weeks. Right? All right. So let's go ahead and prompt for input first. Well, let's do an interactive program like we've been doing. Printf, please enter a, right? The first coefficient. How do I read in a? Scanf, right? And I'm going to be reading in, should a be an integer or a double? Double, okay, because not all coefficients are going to be, just integers, whole numbers. So what's my placeholder for a double? %lf. Read in a. Some problems with this program already, right? Yeah, go ahead. Yeah, what is a, right? In fact, if I tried to compile this, several problems are going to pop up. But the very first problem is a is undeclared. Right? Declare your variables before you use them. You have to. That's a statically typed language. I'm going to use a, b, and c, so I'll declare them all right away. I could also initialize them all right away, but I know that I'm going to immediately read them in from the user, so there's no point. Right? All good now? So far? Nope. What is that message telling me that I forgot that magic symbol in front of the variable whenever I use scanf? Ampersand. Again, magic for now. It is the referencing operator that gets you the memory address of that variable so that you can pass it by value, or by reference instead of by value. Put that in the back of your mind, and we're going to explore that in week 6 or 7. All right. Well, I need to do it for B, and I need to do it for C, right? So B, C, C. There we go. Yeah, okay. What did I do there? I copy pasted, copy pasted, copy pasted. And that leads to mistakes, the intentional mistake there, of if you're going to copy something, modify, copy something, modify, copy something, modify. That's not a good pattern to fall into unless you are absolutely sure that you've changed everything. Right? One of the common problems we saw with the GitHub exercise was folks were trying to type out that token. Unless you are, I don't know if you know who Mavis Beacon is, but Mavis Beacon teaches typing, right? Unless you are the best, absolute best typist in the entire world, you're going to screw that up, right? Don't do that, right? Don't copy, we call this copy pasta, right? Copy pasta leads to spaghetti code. Spaghetti code is an indecipherable mess because you can't tell where one noodle begins and ends, and it's indistinguishable from all the other noodles, right? It is a mess code that is not readable. So generally don't copy pasta because you lead to mistakes like that, right? All right, great. Let's have an output. What I'm going to do is I'm going to do some iterative development here. I don't want to compute the roots yet. I want to test to make sure that everything that I've done up to this point is correct. Because if I don't, and if I end up writing a big giant program of 1,000 lines of code or something like that, and then that's the first time I compile it and test it, right? I might have 50 different errors that were introduced all along the way, right? And I'm going to have to take care of each one of them individually. Whereas if I kept it small, wrote 5, 10 lines of code, test it, at least make sure that it compiles. 5 more lines of code, test it, make sure at least it compiles, test it, test, right? Going through this iterative process over and over, especially at the beginning, is going to help you not to have those 50 bugs in 100 lines of code, right? So I'm going to go ahead and print out immediately that the the roots of %f x squared plus %x f x plus %f. %f's are going to be my placeholders for A, B, and C. Because they are doubles, I am using %f. You can probably get away with using %lf with printf 99 times out of 100, right? But I'm going to use %f here to be safe. Right? Let's see if this actually works. It compiled with no issue. Right? A dot out, 10, 20, 30. Right? Oops, sorry. Never mind. Ignore what I just did. I forgot that we were doing interactive first. 10, 20, 30. 10, 20, 30. Does it look good so far? Good, right? We're doing ad hoc testing as we go along, right? Testing as we go along so that we don't make a mistake that we have to then come back and fix. Now let's compute those roots. Double root 1 is equal to negative b plus minus, can't do that, right, plus square root of b squared minus 4ac all over 2a. Lots of problems there, right? Let's start left to right. First of all, a, b, and c and root 1, are those good variable names? They're not great, but isn't there anything better? Not really. We're talking about an abstract idea in mathematics here. You could, of course, call it, I don't know, the first root of my quadratic formula or equation. Right? That's a terrible variable name. Don't do that. Yeah.
It's like those situational variable names you talked about where it's like X, Y.
Right. If it just stands for generic math, then yeah. Exactly. I can't think of anything better, right? Remember, there are only two difficult things in computer science: cache invalidation and naming things. What's better than good? Good enough. We're done. Right? Negative b plus square root. That looks good so far. Can I do b caret 2 to get squared? Nope. That's a exclusive OR operator, bitwise exclusive OR operator. It will compile and run, but it won't run because I'm mixing it with other things here, or it won't compile for other reasons. Some languages, say if you've ever seen Python, will allow you to do something like this. Star star is the exponent operator. C ain't one of them, right? Instead, what you could do is go with POW. Remember POW? That's in the math library. B raised to the power of 2. Even better, this is a sledgehammer to drive a nail, right? You don't need a big giant hammer when a small hammer will do. It's just b squared, right? B times b. In fact, the compiler, if you did the original right here, the compiler will see, wait a second, power of 2? That's just a multiplication b times b. It's going to end up replacing your code with simpler code that's more efficient. So at the end of the day, this is actually going to get compiled away anyway. So either way is okay. Keep going left to right. Is this correct? Nope. You need explicit operators, all right? 4 times a times c. It is not algebra where you can write 4ac or 2a. Right? All good? Order of operations, PEMDAS. Right? If you wrote it like this, what would happen? Negative b plus this thing. Okay, now I've got a sum, right? All divided by 2, despite my white spacing here, right? And then what would happen with a? A would go from the denominator up into the numerator, right? That's wrong. you can afford to write some parentheses to get what you want. Right? Better. Okay? What's the other root? Root 2 and minus. Okay? Now let's see if that works. R, %f, and %f. Right? And I will output root 1 and root 2. There we go. Compile it. Uh-oh. Now that I'm using math library square root, it's saying, wait, I don't know what a square root is. Right? So the trick here is you have to tell GCC where to find the math library by providing this flag here, -lm. -lm says link into the math library wherever it happens to be on the system. There's a historic reason for why it's done this way. It's a stupid historic reason, but that's the configuration that we're living with on this particular machine. Move it over to a different machine, and there might be a different configuration where you don't have to do this, and it does that heavy lifting for you. The heavy lifting of writing -lm, right? So we'll just have to do it that way for now. There are notes in your hack, too, that when you go to start using like arc, sine, and all tangent and all those other trigonometric functions, remember to use the -lm flag. Right? That produces a dot out. Okay. So give me your favorite coefficients to your, I don't know, 2, 1, and 4. Yeah. Nope. No. All right. 2, 10, and 4. Right? Those are my favorite coefficients. Right? Because they work. How do I know I'm right? Is that correct? Yeah, do the math. Pull out your calculator and verify. Right? That's called testing. That's what the web grader is doing. Anytime you put your code in, what we've got is expected output because we computed it, right? We've got the input, which is hidden from you inside the computer, right? It's feeding input. We've got the expected output. We've got your output, and then we grade. Do they match? Yep, pass. Right? They don't match. This is what you should be doing. There's something wrong, right? Don't automatically assume that the web grader is wrong, right? By now, all the bugs have been worked out. You go back to your code, fix it. Do I get a better answer now, right? In fact, that's a test case. We'll get into more formal testing later on when we actually look at unit testing, right? Both informal unit testing and then formal unit testing using a library. For now, though, we're just going to use ad hoc testing. I'm going to pull out my calculator called Wolfram Alpha, right? And what were my coefficients again? 2, 10, and 4. Roots of 2x squared plus 10x plus 4. 2, 10, 4. There we go. It always gives you symbolically. That's okay. You can click on it. Negative 4.56. Negative 4.56. The other one should be negative 0.43. And it is negative 0.43 right here. Right. See it? Okay. Excellent calculator. Right? So I have a pretty good, do I have a guarantee, a proof that this program is correct? Nope, but I have some confidence that it's correct. Right? If I wanted to have more confidence, what should I do? Try other values. 3, 20, and 5. Right? Go back to your calculator. Does that work? Right? Does that work? Does that work? Another way that you can do testing is to try to be adversarial and to try to break things. Right? That's the fun part. So how could we break this? 0, 4, A? All of them? Oh, all right. Let's just go with A for now. Right? And what's going to happen? Predict. Divide by 0. Right? And we get roots of not a number and negative inf. Why? What happened? What kind of quadratic equation has a coefficient of 0 here? What happens to that term? It's a linear equation, right? And that has a different solution. The solution to a linear equation is minus c divided by b in this case. Right? If b happened to be 0, then what do you have? Nonsense, right? Unless c is equal to 0. There we go. I'll restore that. So we've got some corner cases here, some edge cases that we have to consider, right? What if they gave us 0? Then we could give them the solutions to a linear. Oh, hey, you must have meant that you wanted to solve a linear equation. We'll go ahead and do that for you. Or bad input. Don't do that. Kill the program. Or I'm going to use 1 instead. Right? You gave me 0. I'll just use 1. Right? That's probably the worst solution to it. Right? But you need to start being able to make decisions. And that's the next module, which is conditionals. Break it again. We'll go ahead and go with 3, 1, 10. What's going to happen here? B is very small, so B squared is going to be small, meaning that 4AC is going to be very large. So what's going to happen to my radical right here? Yep, not a number, not a number, right? We can't handle negative square roots. Bring in a library to use imaginary numbers, complex numbers, right? Okay, that's another way we broke it. So we're going to have to think about the ways of addressing this, but we need more tools. We need conditionals, okay? For now, what I want to do is I want to finish this out by changing it. I don't want to read interactively anymore. I want to read non-interactively, right? So instead of prompting for A, B, and C, I'm going to set A equal to something, B equal to something, C equal to something, right? What are those somethings? Those somethings are command line arguments. Somebody's going to invoke it like this, providing actual numbers for A, B, and C. Okay? argv sub, the first user provided command line argument is going to be 1. Remember, 0 is going to be that a.out, right? argv sub 0 is always that first executable file name. So, can I do that? Nope. argv is argv. I misspelled it up there. Sorry. There we go. Error. Incompatible types. One of them is a double. A is a double on the left-hand side. And argv is, it's telling me that it's a char star. We'll understand what that star is later on. It's a pointer. That just means that it's a string. String, a sequence of characters, number, those are incompatible. How do we convert from a string, an alphanumeric string, to a floating point number? Right? Because it's a double. We surround it with A to F. There we go. Copy, oops, copy, paste, paste. Yeah, go ahead.
Could you use the double modifier instead of A to F on that?
No, I mean, you could. Let me show you what happens then. Let's go ahead and make sure that this works before we break it again. Right? Run that. Now I'll go ahead and go with A.out. One of them worked. What was it? 2, 10, 4. There we go. We should expect the same answers as before, and those look familiar. Right? Now you asked, well, can you do this instead? Can you use typecasting to get what you want? I believe that the compiler will no longer complain about this. Okay, it is. Oh, wow. It's a full-on error. I did not expect it to be a full-on error. I expected it to be a warning. Right? But no, you can't do that because it doesn't know how to convert that. What it's going to end up doing is it's going to end up taking that memory address and attempting to treat it like a number, and then it's just going to be garbage. At best, it's going to be garbage, but at worst, very, very good compiler, right? Good compiler. Always warn me of that kind of stuff. Right? In fact, prevent me from doing that kind of stupid stuff. All right, let's come back over here, recompile it. Remember that I'm compiling with that -lm flag still. And let's go ahead and give it those other values that we tested. Right? Again, bad, nan, inf. Right? If we've got something that is small, 10, 1, 10. Right? Again, nan. Right? But there's another way that we can break it now. What if I don't give it any input at all? This program is written to expect 4 command line arguments technically, but at least A, B, and C, the first one being the executable file name. What happens when I don't give any? A segmentation fault. It killed my entire program dead. Why? because I attempted, under the hood, we'll understand this later, under the hood, I attempted to access memory that did not belong to me. Right? On a computer, there's memory. The operating system owns memory. It hands it out to different programs to operate and run in memory. But when one program tries to access memory that wasn't given to it by an operating system, that's bad, right? What if you could arbitrarily access any memory that you wanted with a program? You could access the memory that holds your GitHub token, right? You could access the memory that holds the operating system program, and you could muck with it, right? You can force the operating system to do something else than it's supposed to, right? Huge security issue. And so when it detects something like that, it kills a program dead with a segmentation fault. Segment is referring to a segment of memory. A fault means, well, not your fault, but it's a fault like a fault line, right? A mistake or an issue that happened, right? So it says, nope, you can't do that, killed it. Right? We're expecting 3 command line arguments here. As a preview or dovetail into the next module, let me show you how to check. Are there a correct number of command line arguments? If. An if statement is a conditional. If whatever I put in parentheses happens to be true, then we'll go ahead and execute this statement right here. I want to make sure that there are 4 command line arguments. I want to make sure that argc, the count, is equal to 4. If it's not equal to 4, right, that's how you read this, then we're going to issue an error. Right? Printf error. You must provide 3 numbers. ... Right? And then we'll rudely quit on them by exiting. Right? We're going to just exit the program at line 19. Consequently, the rest of the program does not execute. The program dies right there. Right? Don't worry about the one. That's an exit code. We'll talk about exit codes when we talk about error handling later on. Right? But otherwise, I'm communicating to the user, look, here's how you use this program. Right? You've got to provide 3 numbers. If you don't, I can't do anything, and so I'm not going to do anything. Right? Let's compile that, and let's try it again. Regression testing is testing things that you've tested before after you make changes, so you don't make sure that you didn't break anything. 2, 10, 4. Remember that worked before? I want to make sure that it still works, and it does. But now I have addressed this other problem of not providing any command line arguments. And that works too, if you want to make it prettier. Hyphen, or \n, so that it goes to the next line. Right? It was all mashed on the same line, right? We don't want that. Error, you must provide 3 numbers. All right, fine. 10, 20, 30, 40. Did I provide 3 numbers? Nope. So I provided enough numbers, but it was looking for exactly 3, right? Other things that you can't control just yet, right? A.out, 10, 20, 30. Right? So those are 3 numbers, aren't they? Not according to a computer. What will end up happening here is that C will end up being parsed as a 0. Right? There it is. So it still worked, but it didn't give me what I wanted because I said that C should have been 30. Right? English does not work well with computers here. Right? Why did I check to see if it was 4 again? 3 numbers, but what's always the first command line argument? A.out, right? The executable file name. And so it had to actually be 4 to get those 3 numbers. All right, any questions on that? Good. Then I will cut and paste it and put it in your notes so that you have the entire thing. Right? And if I were to hand this in as my solution, I would probably lose points on this stuff right here. Remember what we called this? Cruft, right? Don't leave dead code in your submissions, right? I got rid of this because I wanted to do it a different way. Or maybe I had a bunch of debugging code. Print this statement so that I see what value it is. Print that statement so I see what value it is, right? And then, okay, well, I don't want that in my actual output. I'll just go ahead and comment it out, right? No, delete it. Kill it. Get rid of it. It's dead code. Right? Otherwise, other than that, it's a pretty good submission. Other than this, do I have any other comments? Nope. Good, right? You do not want verbose comments, like lots of comments, right? Why? Because it's self-explanatory, right? Now you have a week and a half of C under your belt. This is self-descriptive code, right? It's self-documenting code. Everybody now knows that this is declaring your variables. I don't have to put that in a comment. Everybody knows that this is reading command line arguments. You don't have to put that in a comment. You know what this math is doing because of this sentence up here, right? And you know what this print statement is doing. Right? It's all self-explanatory, self-documenting. There should not be any comments in here in such a simple program at this point. Okay? All right. No questions? All right. Then let's start talking about the ins and outs of this thing here, right? Conditionals. And to do that, I'm going to have to launch another note set here. Yep, good. Oops, went off screen. Yeah, we've got 10 minutes left. We can cover it, at least initially. All right. So the regular control flow in a program proceeds as it would be in English. It's called sequential control flow. That if you've got a statement A, statement B, statement C, that's how it executes. A, B, C. Top to bottom, left to right. Because that's how we read English, right? However, more complex problems require decisions. Should I do this or that? Should I do this or not do it? Should I do this thing or this thing or this thing or this thing, right? And that's where you bring in conditionals. Conditionals are how you can specify that either code executes under one condition or it does not execute at all. Or you can specify that under some condition, one piece of code executes, otherwise a different piece of code executes. Right? And these are all done in code using if statements. Note there that I'm putting that in nice script. If, that is a key word. That's code, right? If statements, if else statements, or if else if statements. There we go. They're all actually the same. It's just in how you use them is different. An if-else statement is the same as an if statement, just with an empty else block, right? To do this, you're going to need some logical condition, right? Logical conditions are things that are either true or false. Boolean logic. Right? You might have had a logic course, maybe, maybe not. It doesn't matter. It's okay. We're going to cover all the logic that you need. It's a statement that is either true or false, right? It's nowhere. It's not in between. It's not a half truth, half false, right? It's not I don't know. It is true or it is false, one or the other. It can't be anything else, right? Now, I am not highlighting true and false using this coding script right here because those keywords are not supported in C unless you bring in a library. Right? And do forgive me for any misspellings. Hey, you know what? This actually gets pushed out to GitHub later on. If somebody wants to go in and correct all the spelling and make a pull request, go ahead. Right? I don't care about misspellings that enough to actually take care of it. Right. So let's talk about basic syntax before we adjourn today. And let me show you now this is not real code, right? Because this is not a real condition. Right? But I'll have an if statement here with a condition in it. We'll talk about conditions on Friday when we get to it. But otherwise, you'll have a code block here. If, and then parentheses, and then inside that you put a logical condition that is either true or false. Right? You have an opening curly bracket and a closing curly bracket. And anything in there, if the condition evaluates to true, everything in this block of code will execute. Right? Otherwise, none of this code will execute. And normal control flow continues after it. In other words, this line right here. After this line, it'll just jump down to the ending curly bracket and continue with whatever else is in the program. Okay? We've seen that right here. If argc was not 4 because I didn't provide any command line arguments, it was 1. Is 1 equal to 4? Nope. Therefore, this evaluated to false when I didn't give it enough command line arguments, right? And, it's not equal to 4, so it evaluated to true because 1 is not equal to 4. And so, therefore, everything in this code block executed. Well, guess what? It exited the program at that point and killed the entire thing. Right? So none of the rest of this actually executed, but that's only because we exited. Right? Let me go ahead and open up demo here, and let's do something else. I'm going to show you one very, very simple if statement here, and then we'll call it. Int a is equal to 10. Right? So if a, and here's how you check for equality. This is a preview of Friday. If a is equal to 10, then we'll go ahead and print out Huskers will win this weekend. Right? Yeah. They were 12-point favorites last week, and they still couldn't cover that spread. So I don't know what the spread is this week, but I'll take them not to cover. I didn't actually. Don't gamble, right? Anyway, is a equal to 10? Will this execute? Will the Huskers win? Well, yes, because a is equal to 10. What if it's not equal to 10? What if it's equal to 20? It doesn't print anything. So what do we need if we want an alternative? And saying that the Huskers will not win, unfortunately? An else statement. That's a preview of Friday. Printf. Don't make any bets. All right, there we go. And now that one will execute because a is not equal to 20. Now, whether or not the variable I just set there has any bearing on their performance this weekend, no. But yeah, don't gamble, especially on Husker games. All right, we'll see you next time.